Hello students, so my channel Clear Your Doubt is going to help you in your preparation journey. If you are a NEET-UG student, you can ask questions, doubts from physics only. If you are a JEE mains or advanced student, you can ask questions from physics and mathematics both. Okay, so let's do this question. It is from rotational mechanics, although horizontal circular motion is involved mainly. Okay, and other fundamental concept. Okay. So let me read the question for you. A uniform rod of mass m and length l rotates in a horizontal plane, okay, with an angular velocity omega about a vertical axis passing through one end. Okay, so as you can see in the figure, so this is the vertical axis and about which this rod is doing horizontal circular motion, all right, with angular velocity omega. So what you have to do is you have to find tension in the rod at a distance x. Okay, so let's just assume from the axis. Okay, so from the axis let's just take a strip of dx. Okay, so dx, and this would be x, and this strip is dx. So if total mass of the rod is m, total mass is equal to m, then what would be the mass of dx? You are going to assume linear mass density, right? M upon L into dx. Okay, this is going to be mass of dx length, and that let's call it dm. All right. Now, tell me one thing. So, if it is doing horizontal circular motion, then there would be centripetal force acting on it, right? Centripetal force will act towards the center of the circle, and that would be how much? Mass centripetal force. Centripetal force is equal to dm into omega square into radius. So dm would be at a radius x. All right. So now this centripetal force is going to be balanced by what? Let me tell you something. One more thing. So if this centripetal force is going to act towards center, then there is going to be a tension force in the rod on this thing on the opposite side. Okay, if you are considering only dx, और dx में अगर आपका टेंशन dt है and this dt is going to act to the rest of the mass, listen to me carefully, to the rest of the mass. Okay, this centripetal is going to act on this thing, this whole thing, right? So at this point, at this interface, this gt is going to act to the rest of the mass, so rest of the rod, that means on the right side, and this is going to act basically if you are cutting that dx portion here. So this is what it is. If you draw fbd, it is going to be dm omega square x, and on this side it is going to be dt, and when you'll balance it, so since they are in opposite side, you can assume that this will be balanced by minus dt, right? Do not think that they are opposite sides so they should be just equal. No, not like that. So minus dt is equal to dm omega square x. Now put the value of dm, that is m by l into dx ओमेगा स्क्वायर एक्स. इसको थोड़ा सा सिंप्लीफाई कर लो, m ओमेगा स्क्वायर बाई l x dx is equal to minus dt. Now limit of integration from x to total length of the rod, and tell me one thing, at total length of the rod, is there any mass would be present on which tension can act? No, right? यहाँ पे कोई मास तो है नहीं towards right at the end at x equal to l, तो वहाँ पे टेंशन क्या हो जाएगा? जीरो. एंड एक जनरल टेंशन at x length would be t, right? और dx का इंटीग्रेशन x होता है तो सिमिलरली dt का t हो जाएगा, तो ये आ जाएगा t. लिमिट रखोगे तो ये t आ गया ना, जीरो माइनस माइनस टी दैट इज t, और यहाँ पे क्या आ गया? m ओमेगा स्क्वायर बाई l x स्क्वायर बाई टू, सो यहाँ टू ले लो और ये हो जाएगा लिमिट रखने पे एल स्क्वायर माइनस एक्स स्क्वायर. ऑलराइट. Unit could be anything. Okay. Alright, so thank you so much for watching the video. Do subscribe to my channel if you think you have learned something from the channel. Okay, something from the video. Have a great learning. All the best. Thank you so much, and do share the video as much as you can, and do subscribe it if you have not already subscribed it. Okay, bye.